Okay, good morning. So let us actually continue our lesson. Just refresh you a little bit. Uh, if you remember last time, we started the modular arithmetic, and then we defined congruency of two integers like this. So I told you that m, which we call the module, uh, is a natural number, and because we are interested in more interesting cases, we exclude 1 from it. So we start from 2. And then I told you that a and b are integers. We write a is congruent to b modulo m if and only if what happens? If and only if the number on the left minus the number on the right is divisible by m. So that was the definition of congruency of two integers in some module. And then we realized that usually, mainly, what you expect for equality sign is also valid here. For example, two numbers are equal. Here we learned that any two numbers are also congruent in any module that you want. I don't know if a is congruent to b, b is also congruent to a, and if a is congruent to b, b congruent to c, a is congruent to c. So that long theorem, yes? So, but there are two operations, do you remember, which were not in general valid when it comes to congruency. One of them was division by a number, even if after division you will still have integers, yes? So that was not valid. Another one was, yes? And through. Taking roots are not in general allowed. Okay. And then we started solving some problems together using those. So you should be able to improve your skills in simplifying expressions in given module. Okay, so let me start with an example today. By the way, I also told you that there is one special case that we are particularly interested in, and that is the case when b is equal to 0. If b is equal to 0, this means that a is congruent to 0 modulo m if and only if what happens? M divides a. So that is a special case that we are interested in. Why? Because in the previous lessons we are interested to see if a number is divisible by another number. So that's a good way to do it, because you can translate the language of divisibility to the language of congruency, and then you can use a lot of theorems in congruency to do them faster and more efficiently. So that's one particular case that is important to remember in particular. And let me give you another example of this type, okay? So example, prove that (11) divides this number 141 to power 62 plus 62 to power 141. So these numbers are extremely huge numbers. I don't know if the calculator, very small display of calculator, is capable of proving this for us. Of course, probably if you have softwares, you can just, and computer handy, you can confirm that. We can also check that later. But the point of this exercise is proving this without any digital aid. So this is exactly what I want to do. Whenever from now on, of course, the methods that we have learned is not obsolete. You can use them, but using the congruency language is more efficient. So what you see is that this number is going to play the role of this m, and this big number here is supposed to play the role of this a. So the first thing that comes to mind, if I have decided to solve this problem using this new technique, I translate this into the language of congruency. Yes. So instead I would say that, okay, instead of proving this, I can equivalently prove what? I can equivalently prove that the number on the right hand side, 141 to power 62 plus 62 to power 141 is congruent to 0 modulo 11. Yes, so this is my question mark. If I can confirm that, because this is equivalent to this statement, I'm done actually. Yes, so we have to start simplifying this expression in that module so that we can show that this is actually 0 if you are working in module 11. Okay, and I already told you what to do. Yes, the first thing, you cannot do anything with exponents, but you can get rid of very big actually bases. Yes, for example, 141 is quite above 11 and 62 is also the same, so we can actually make them very fairly small. So what can I do? So do you have any idea what to do? Yeah, you should have an idea. It is not hard. So for example, can you give me another name for 141 when it comes to 11? I don't know, do you know multiples of 11? So if you have, sorry, not multiples of 11. Yeah, you can consider multiples of 11 or powers of 11, I don't know. But I know that 11 times 11 is how much, do you know? 121, yes? Okay, so instead of this number, do you agree, for example, I can write 20? This kind of calculations, I want you to be good at it, okay? So instead of 120, instead of 141, I can write 20. Why is that? Because 141 minus 20 is 121, and 121 is divisible by 11. Yes? Is that clear? So when you say that two numbers are congruent, it means the number on the left minus the number on the right is a number which is divisible by the module. So another name for 141 is 20. I'm not saying this is the best number. I'm just choosing one number. I want you to see this immediately, that 141 is 20 if you work in module 11. Why? Because 141 minus 20 is 121, and you see that 121 is divisible by 11. Yes, so that is a good name. So instead of 141, I can work with 20. It's much better than working with 121, but not that good enough. But for the time being, let me just write it here. Okay, I want to wait for you now. What do you write for 62? Yes? Yeah, minus 4 I think is a good one. First, I want you to understand why another name for 62 is minus 4. Because 62 minus 4 becomes 66, and 66 is divisible by 11. So what Abdullah said is actually correct. So, but still, there are many things we have to address, because still, of course, this is much simpler than this number, but still for our brains it's too big. Okay, I want to wait for you. Any other ideas? Because still 20 is above 11. Yes, whenever you have a base which is bigger than your module, you should think about reducing it. So we can reduce 20, yes? What is a good candidate here for 20 when it comes to module 11? Yes? Negative 2 is the best one. Yes, of course you can also write 9. Why 9 is correct? Because 20 minus 9 is 11, and 11 is divisible by 11. So instead of 20, you can write 9, but I myself prefer to work with minus 2. which from the size point of view is smaller. Okay, so hopefully you know what to do now. So what you have to write, I would write minus 2 to power 62. Yes, and then I have minus the plus minus 4. And by the way, can I bring this minus sign out? Yes, because this is an odd number. So minus a negative number raised to an odd number remains negative. So it doesn't, I don't need to write plus or minus. I can just simply write minus 141. And by the way, can I get rid of this minus sign here now? Yes, because now you see it is even. So it will actually, we can get rid of this minus sign. So let me just, okay, let me take it in another step. So if you don't mind, let me write it and then remove it, okay? So here, I just remove it because it is even. Here, I put the negative sign out because that exponent is odd. So, and then I would write the module 11 here. Of course, it's a good progress because instead of working with this number, I work with this number, which is quite simpler, but it's still very, very big number for our brain, yes? So then what should I do? Do you remember there were 3 ideal cases if we have high powers? What were the ideal cases? Yeah. So we can, if possible, we look for a power which is congruent to that number either with 0 or 1 or minus 1. Of course, if it is possible. But do you think it is possible? So what you need to do, you need to have a list of powers of 2. Yes, 2 to power 1 is 2, 2 to power 2 is 4, to power 3 is 8, to power 4 is 16, and then to power 5 is 32. By the way, 32 is a good number, because what is the closest multiple of 11? So you see, multiples of 11 are 11, and then 22, and then 33. So you see, you have your what you need, yes? Because these are powers of 2, and these are multiples of 11, and then exactly here, I have my ideal situation that the difference is exactly 1 unit. So then it tells me what to do, yes? So I would write this in terms of this power. What was this? Do you remember? It was 2 to power 5. So what I do, I would write it as 2 to power 5, but I want to make it 62. So what can I do? I raise it to power 12, but that is not enough, because 5 times 12 is 60. How many of them I need? I need 62 of them. So what I have to do, I have to multiply it by an extra power of 2. So what was the motivation behind this way of writing? Because I want to write 2 to power 62 in terms of 2 to power 5. Yes? And then if you decide to do this, this is the only way we can do it, because 2 to the power of 5, I want to make it 62, so I raise it to the highest power so that I reach to this limit, but I will not be able to go beyond that, because if I go beyond that, I have to divide, and division is not allowed. So it means that I have to make myself as close as possible to 62, but I'm not allowed to go beyond that. So, and then this 12 is the best number, because 5 times 12 is exactly 60. But then you realize that there are 2 more exponents that you need, so you just add them manually by hand there. Yes? Okay. What can I do about 4 to power that one? Either you can start writing powers of 4, but it's not necessary, yes? Because 4 itself is 2 to power 2. Yes, so this means that this expression is 2 to power 282. Do you agree? Because 4 is 2 to power 2, and if I multiply the exponents, it becomes 2 to the power of 282. So another name for this, whose base is 4, is this number whose base is 2. Yes? So then I have the same story. I have a power of 2, and then the good power of 2 that I need is the fifth power. So what I can write minus. There is a minus here. Instead of 2 to power 282, tell me what to do. What I'm supposed to do? What should I write? I should write 2 to power 5, because 2 to the power 5 is something that I need, yes? And then I have to go and construct 282. So how should I do that? 56, yes? Let us check. If I multiply 5 to 56, it becomes 280. Then, and then you have another 2 to power it. Yes? Okay, now can you tell me, so now I am working in module 11. In module 11, 2 to power 5, which is 32, has a better name. What is that name? What can I write instead of 2 to power 5? 2 to power 5 is 32. Yes? Negative 1. Why? Because 32 minus minus 1, this is 2 to power 5, minus minus 1 becomes 33, and 33 is divisible by 11. So another name of this, when I am working in this module, is negative 1. So then it becomes equal to, sorry, we can just write congruency. So minus 1 to power 12, and 2 to power 2 is so simple we can calculate, it's just 4. And then minus, the same story here, minus 1 to power 56 multiplied by 4. But then hopefully you understand that what's going on, because minus 1 to power even becomes 1. And 1 multiplied by 4 is 4. And then the same thing here, minus 1 to power 56, which is even, is 1. Multiplied by 4 is 4. But I have a negative sign here. Yes? And then 4 minus 4 is 0. So you have to practice to be a little bit fast in these kinds of calculations. So if you have high powers of relatively small numbers, what I do, I usually try to visualize the powers, some powers that I can calculate it with my head, of course, yes, in my head. So I calculate them, and then I also write a list of multiples of my module to see if there is an ideal situation that I can catch, yes. If that is the case, I will work. If I cannot find this one, based on my calculation and abilities, then of course I have to raise the power gradually. I cannot raise it exponentially. So for example here, the reason that 56 is a very big power for us, but the reason that this was good, because accidentally or coincidentally I was able to write minus 1, which is the ideal situation. Okay, if it is not the case, I have to increase and then lower it again, increase it again, lower it again, something like that, yes? So you have to actually play around with that. So I will give you some examples of that type, that you have to do these kinds of things at the end. Any questions to understand this? Okay. So this one thing that you have to be very good at is to be able to write different names of numbers in a given module. So you shouldn't be very slow in this kind of calculations. For example, in this module 11, when I say what is another name of 32, you should be able to say minus 1 more or less immediately. Okay, or at least when I say that, you should immediately see it why this is true. Okay, so there is another part of the lesson that is important, is this, and we already talked about this more or less before. So assume that I give you a, which is an integer, and I give you m, which is a natural number, and greater than 1. And the question is of this type, yes? This is the question. What is the remainder on division of a by m? Of course, this is not a new question. We already solved a lot of problems related to calculating the remainders, but the numbers involved were fairly small. That's the same question, but the point is that I want to answer the same question if this number is a big number. Or actually a huge number, yes. So this is the point. So the lesson is not new. When I ask you what is the remainder from the division algorithm, you know what to do. You need to find this. You need to find this r, but you need to know that r should be somewhere starting from 0 up to m. So when I ask you to find the remainder of a by m, I'm asking you about finding this number r with that property. And we solved quite a lot of examples related to this. But the question is the same question. Still, I am interested in this. But the point is that I want to give you a to be a very huge number. And I want to ask that. For example, if I give you 21 as a, and I give you m to be 5, if I ask you what is the remainder of 21 by 5, what you do, you write 21 is equal to 5 times 4 plus 1. And because 1 satisfies this condition, you say that 1 is the remainder. So the point is the same, but I want to give a huge number, and I ask you the same question. And I want you to use these kinds of modular arithmetic to be able to answer that question. Yes? Is the question clear? Yes. So, but how should I write this in the language of modular arithmetic? This is easy because so what is my question mark? My question mark is on this one. So what I do, I move a r to the left. So this becomes a minus r is equal to mq. But what is the meaning of this when it comes to divisibility? This means that m divides a minus r, and vice versa, of course. But this one can be written in the language of congruency. You see, here compare the last statement with this statement. M is the same M, A is the same A, but instead of letter B, I have letter R. So I can translate this divisibility statement into congruency statement. Yes, so what happens? This means that A is congruent to R modulo M. Yes? But this extra condition is important, that R should also satisfy these two conditions. It should be greater than or equal to 0, and it's strictly smaller than M. Yes? So whenever I ask you to find the remainder of A by M, you could do it as before, but a more efficient way, especially when A is a huge number, is to use the congruency language and try to simplify the huge number A to a number which satisfies this condition. It is greater than or equal to 0 and smaller than the module that you see up there. Whenever you find that number is unique because of the division algorithm, and everyone can say that, yes, this number is the remainder that you are looking for. For example, of course, in this case, if I ask you what is the remainder of 21 by 5, you could do this. You can write 21 on the left, you can have the congruency in module 5 and ask yourself, what is another name of 21 in module 5? Of course, there are infinitely many other names, but I am interested in the one which satisfies this condition. It should be greater than or equal to 0, and it should be strictly smaller than 5. If you want to make this right, there is only one possibility for you to write that. So what is that number here? For example, I can write -4. This is not wrong because 21 minus -4 is 25. 25 is divisible by 5, so it's true. But I cannot accept this as the remainder because it does not satisfy this condition. So which number is that? 1. Why? Because 21 minus 1 is 20. 20 is divisible by 5. On the other hand, 1 satisfies this condition, so the number that I am looking is 1, which actually confirms that as well. Yes. But if this number is so big, this is not possible, but this one is still possible. Yes. Okay, so let us just give some more examples here. Okay. So you, this is one type of examples that you can find in the book. So they give you a huge number. They ask you for finding the remainder of some division. Yes. So let us just do some practice here. So example. Determine the remainder on the division of 4 to power 100, no, 2 to power 103 by 31. So that's exactly an example that now you are more familiar with it because of that calculation of the previous example. But I want you to understand how to translate this problem into congruency language based on what I told you here. So whenever you see this problem in a scratch work or whatever you want to, wherever you want to, you have to have this idea. You need to stay, they in an indirect way, based on that explanation, they are asking you to simplify this number in that module. Instead of saying simplify this in this module, they have asked you to determine the remainder of the division of this one by that one. So this means that you need to answer this question. Where R is missing. But R should satisfy this condition as well. It should be greater than or equal to 0 and it's strictly smaller than 31. If you can manage to answer this question mark where this number satisfies this condition, that is the answer to the problem. But I want you to understand. Do you understand that? That's exactly what I told you there, yes? If you somehow manage to write A as R, where R satisfies these two conditions, then this R is the remainder of the division of A by M. Okay, so when you read this sentence, you need to understand that they are asking you this question. Okay, so what you need to do then, I think it is extremely simple. Can you tell me what to do now? Because this is not a new lesson. This lesson now is the old lesson. You have to simplify this expression. This number, I would say. So what do you think? Again, let me tell you. You go to a scratch work. On the one hand, you write multiples of this number, but this is big. But so the first multiple is 31 itself. The second multiple is 62. I don't know, some of them. So 93, but of course this list will go forever. And then on the other hand, you start writing the powers of this number. Okay? So what can I do? I can write 2 to power 1, which is 2, and then 2 to power 2, 4, 8, and then try to seek the ideal situation that I have a difference of 1 or 0. Okay? So 8, and then 16, and then 32, and that is your case, yes? So this means that you now you have some kind of ideal situation that the multiple of this differs exactly 1 unit from some power of that. Okay, so this means that this, do you remember it was 2 to the power of 5? So it means that I have to write this in terms of 2 to power 5. So this means that I write it 2 to power 5, but this is 2 to power 103. So I have to raise it to which power? 20, but it is not enough because 20 times 5 is 100. I need 3 more. So I just add it by hand by multiplying it by 2 to power 3. Yes? And then I continue. Okay, what is another name of 32 when it comes to module 31? What is another name for that? Yes? No? 1. Yeah. So it is just 1. So this becomes 1 to the power of 20. Multiplied by, but 2 to power 3 is so small that I can calculate it. 2 to power 3 is just 8. And then it is simple because 1 to power 20 is 1. 1 times 8 is 8. So what I end up with is 8. Is 8 acceptable? I have to check this one as well. Because 8 lies between 0 and 31, so the answer to this problem is actually 8. Yes? So this means that the remainder of this, which is a very huge number, by 31 is just 8. There is nothing much I can do. The thing is that I will give you some examples, wait a little bit for you so that you can solve it for me, and then we can discuss it on the board together. Okay, so I will give you another sort of this problem. So that is the main lesson. You see, nothing is new. The only thing is that you need to know how to translate this English sentence into the congruency language and do the same thing. So in principle, this problem is even simpler than the previous problem, yes, because the calculations were very straightforward in this case. But this is the only thing that you need to learn today for the time being. Okay, so let us go to the next example. I will write it down here. I will write 2 of them and wait for you, okay? So example. So I will write it in short form, okay? So remainder of 4 to the power of 374 by 9. This is one question. Another question, I change of course the numbers only. The remainder of 2 to power 489 by 13. Okay, I will write one more. Remainder of 2 to power 100 by 19. Okay. So, but what I expect you to do is the first 2. Okay, the third one is not hard, but this is one of those cases that you cannot increase the power immediately because you don't reach to the ideal situation early. Yes, so you have to continue this. So I give you a little bit of time so that you can think about these problems. Okay, so let me solve one of them at least for you. Again, let me explain everything from scratch. So here you want to find the remainder of this number by 9. According to what I told you, so what is your goal? Your goal is to simplify this number in this given module. This you need to understand why we are doing this if I want to find the remainder. And that is the explanation that I provided here, yes? So hopefully you understand, to answer this question, you need to answer this question. Yes? And this R should satisfy which conditions? It should be greater than or equal to 0 as always, but it should be strictly smaller than the module that you're working in. So this question, you should be able to translate it into this congruency language. Everyone happy with that? Yes? Okay. So now you need to start simplifying the left-hand side, which is a huge number in that module. Okay? So this is the trick I use. For example, I have already practiced, so I have a lot of these numbers in my head, but this is the way that you have to do it at least. Try make 2 columns, and then the left hand side, for example, you write some of the powers of this number as far as you can calculate it in your head. Okay, so for example, 4 to power 1 is 4, 4 to power 2 is 16, 4 to power 3 is 64. I don't know, that is probably good. This list will continue, of course, but then our ability to calculate things in our head is limited. So let us just stop here. And then on the other hand, I start writing multiples of this 9 as much as I can and look for the ideal situation, if possible. What is the ideal situation? Is that one number on this column differs with one of these numbers either by 0 or by 1, or minus 1, of course. If not, then that would be the situation of the last problem. I will tell you how to do that. Okay, so let us write multiples of 9. One of them is 9. 18. So far it's not very good. The difference is too much. Not too much, I mean the difference between 4 and 9 is just 5 units. The difference between 16 and 18 is 2 units. It's not bad, but let us don't give up. And the other one is 27. And then, so you see that down there in this list, what do you see? 63. Yes, because 63 is also a multiple of 9. And why this is better than the previous situation is because now I have this difference of 1. There is nothing that I can teach you how to find it. This is the way that you have to think. Okay, so whenever it is clear, so this was the third power of 4. So I will do my calculation based on the third power. So what I do, I would write 4 to the power of 374. I realize that the base of my calculations should be 4 to the 3. So I would write 4 to the 3, but I need 374. So what is the power that I put here? 124 is the best number. Why is that? Because if you multiply 3 by 124, it becomes 372. But there are 2 more powers of 4 that I need. Then I have to put them manually by hand. Yes? I hope that you understand what is going on. If I tell you why did I do this? Because I realized that the third power of 4 should be the base of my calculations, and this is the only way that I can do that. Yes? And then what is the module? The module is 9. If we can go one more step. This number is so simple. I just simply write 16. But instead of 4 to power 3, I can write what? 1. Why is that? Because 4 to power 3 is 64. And minus 1 is 63. And 63 is divisible by my module. So another name for 4 to power 3 is 1. Of course, I also have 124 as my exponent. But because I found the ideal situation, so I'm not worried about this high exponent. Because 1 to power 124 is just 1. And 1 multiplied by 16 is 16. I managed actually to simplify this quite a lot, but this is not acceptable as the remainder. Yes, because the remainder should also satisfy this condition. It should be greater than 0, which is in this case, but it should be also lower than my module, which is not. So then I have to reduce it one more step. So what is the best name for this? Of course, I can write -2, because 16 minus -2 is 18. 18 is divisible by 9. But -2 is not acceptable because I need a positive number. So what's that number then? There is only one number, yes? 7. Why? Because 16 minus 7 is 9, and 9 is divisible by 9. So this is the answer to this problem. So the remainder is 7. So the answer is this. Yes, is that understandable? So this is the general strategy, but these problems could be really hard sometimes. Any questions? Okay, let us do the other one again together. So the remainder of this power by 13. Let me just again explain everything. From the next examples, I will do it faster, but let me just explain everything again. So what I do, I need to translate this sentence, this question into the congruency language. So in a Scratch work, you know that what you are supposed to answer. You are supposed to simplify this huge number, 2 to the power of 489, in which module? Module 13. So you need to answer this question, that what is this R? So that this R satisfies these two conditions. If I can answer this, then I am done. Again, what you are supposed to do, you go to a scratch paper, or where, or you can do it in your head if you are quick. So on the one hand, write the powers of this base. So the first power is 2, and then I don't know, 4, 8, 16, 32, 64, 128, etc., etc. On the other column, write the multiples of your module. So what are they? 13, 26, 39. Have you caught the ideal situation yet? No. Yes, because I want to have the difference to be 1 or 0. Okay, the next one is what? Oh, so that's, sorry, that is not 36. That is 39. What is the next one? 52. What is the next one? 65. And then you catch it here. Yeah, so that's the ideal situation. So which power of 2 was it? It was 2 to the power of 6. So this shows you that it is better to base your calculation on the 6th power of 2. Yeah, so then it is very clear what to do now. So then I will start from the left-hand side. Yes. And then I would say that I have to write it in a way that I see 2 to power 6 in front of me. So what I should write, I would write 2 to power 6, but I need 489. So into which power should I raise it? 81. Do you agree? Because 6 times 81 is 486. Yes? But how many I need more? 6 times 48 is 486. I need to have 489. So I have to multiply by 2 to the 3rd. Yes? Okay, now I think the situation is under control now. So what is another name for 2 to the power of 6 when it comes to module 13? You see here. What is the answer? What can I write? Yes? No. Because it is on the board. You see, this is 64. The closest multiple is 65, yes? Minus 1, yes? So instead of 2 to power 6, you put minus 1 to power 81 times 2 to power 3. Let us check. I am claiming that 2 to power 6 has this name when it comes to 13. Why? Because 2 to power 6 is 64 minus this number, which is minus 1. It becomes 65, and 65 is a multiple of 13. But then you can continue, because these numbers are so small now that you can do it. It's very simple in your head. Minus 1 to power 81. 81 is an odd number, so minus 1 to power 81 remains negative 1. And 2 to power 8, 2 to power 3 is just 8. So this becomes minus 8. Minus 8 is quite a small number, but it is not acceptable because we have to have this is non-negative and smaller than 13. If you stick to this condition, there is exactly one answer that you can provide. So can you tell me what that number is here in this case? Yes? 5. So another name for minus 8 is 5. Why? Because minus 8 minus 5 is minus 13, and minus 13 is divisible by 13. Yes? Is 5 acceptable? Yes, because it is somewhere between 0 and 13. So that is your answer to this problem. Yes? Okay, let me try to do this one. So this is one of those cases, if I remember correctly, this ideal situation cannot happen actually quite early. So you cannot continue. Of course, if you are patient, might be you can find this down the list somewhere. But this is not very efficient. So let us try to see how we can do this problem. So here you have to be a little bit open-minded. There is no very clear way of doing it. Okay, so what I want to do for that question, hopefully you understand that you have to answer this question. So this is what you need to answer. But if you start writing the same thing, so if you go to a scratch paper, if you write powers of 2, so this is 2, and then you have 4, 8, 16, 32, 64, 128, etc., etc. And then if you start writing the multiples of 19, so they are not friendly numbers. For our brain, it would be actually, we will be very limited in how many of them I can write. So 19, and then the next one is 2 times 19, which is 38. 3 times 19 is 57. And then 4 times 19 is how many? 70. 6, and etc., etc. Might be if you are so patient, you will find the ideal situation down there in the list, but we cannot count on it. Okay, so at some point you should give up, yes, and then you start doing this trick. So I don't know, for the thing that you see on the board, which one do you prefer? Which power of 2 we start with? So for example, I myself consider this difference is probably smallest for the time being, yes? So I have 16 on this column, 19 on that column, so the difference is 3 units, yes? Do you have a better situation? No, because if you choose 8, the difference is quite big. If you choose 32, the difference between this one and the closest one is 6 units. So apparently, if I want to choose something, I will focus my attention on 16 and 19 because the difference at least is the smallest as I see right now. Okay, it's not the ideal situation because the ideal situations are 1 unit or 0 units. But this is probably better. So I would say that I will start with 2 to power what? 4. And there is another difference here is you have to start constructing this because you don't know how to calculate. So what I do, I write 2 to power 4 and I have my module to be 19. What can I write on the left hand side if I want to make it right? What should I write here? 19 and 16, the difference is 3 units. So should I write positive 3 or negative 3 here? What? Negative, yes? So negative 3. Because 16, negative 3 becomes positive 19 and 19 is divisible by 19. But now you understand what the situation is. In principle, I can raise to power 25. But 2 to power, this becomes 2 to power 100, that's quite okay. But the point is that minus 3 to the power of 25 is still quite big. Yes? So it means that this is not good if I want to raise it to power 25. It is not wrong, but I will not be able to answer it because minus 3 to power 25 is still a big number. So then I have to do it gradually. By gradually, what I mean, I don't know. For example, you raise it to power as far as you can calculate in your head, okay? By the way, what is the next number coming after that? If I add 119 to this becomes 85. Am I right? Yes. So for example, I would, because I can raise it to power 4 now. What happens? This becomes, let us just do the calculations in our head mainly. So 2, yes? Oh, so that's a bad number. So forget about 4 now. Yes, you are right. That's 95. So 95 is not a good number then. Okay, so if I raise it to power 2, 3, so let us work with 3, okay? Yeah, it doesn't matter that much. Let us raise it to power 3. But let us do the most of the calculations in our head because it would be very messy. If I raise it to power 3, what happens? It becomes 2 to the power of 12. Yes? And then this becomes negative 27. Agree? So I raise both sides to power 3. Whenever this number goes beyond that number, reduce it and then continue. So what is a better name for minus 27 when I am working with 19? What is that? It's not a very good number, you see. But it is, by the way, doable because I am not using calculator. So that's the important thing to realize. So instead of minus 27, either you need to focus here. So how many of them are the 8 units? Yes. So minus 8 I can write. Is that understandable? And please check my calculation. So minus 27 minus 8 becomes positive 8. What is that number? It's minus 19. Do you agree? Okay, so and minus 19 is divisible by 9. So what I have written is reasonable. Yes, it's correct. And it is better than minus 27. Okay, so what is your suggestion now? Of course, the ideal situation is to raise it to higher powers as fast as we can. But the point is that we cannot, because this number becomes a huge number. So let us be patient and raise it to power 2 once more. So what happens? 2 to the power of 24. On the right hand side, what do I have? 64. Yes? Do you agree? And then 64 is, this one is the best choice. Instead of 64, what can I write? I can write 7. Because 64 minus 7 is 57, and 57 is divisible by 9. Okay, for example, another power of 2 will give me 2 to the power of 48. And then this becomes how much? 49. And by the way, this is not the only way. You might be able to find other ways. I mean, with different numbers, but this is one way at least. So I want you to understand, because I didn't have that ideal situation here, what I did, I'm just trying to raise the powers gradually, lower it again, and then raise it. That's the only way we can do it. But instead of 49, what can I write? 11. Agree? Is 11 good? I can write 11, I can write minus 8. Which one is better? So let us keep minus 8. Minus 8 is better than 11 for my brain, yes? Because 49 minus 8 is 57. 57 is in this list. And mainly we are more or less done, yes? Because another power of 2 gives me what? 2 to power 96. And then I will have 64. 19. 64 is beyond 19, so I reduce it to what? To 7 again. Yes? Now we are done, mainly, because I am very, very close to the 100th power. Yes? So how many I need? Now I cannot raise to any power, but 4 of them I need more. So I multiply this time everything by 2 to power 4. Is that understandable? So I reach to this stage. I realize 2 to power 96 is congruent to 7 modulo 9. But I need to know something about 2 to the power of 100. There is no way by raising to powers. I have only 4 exponents less than I need. So this motivates me to multiply by the 4th power of 2 to construct to 2 power 100 on the left hand side. So then immediately it becomes clear. So this becomes 2 to the power of 100, and it is 19. Of course, this is not a big number, but you can do it more efficiently, yes? What is another name for 2 to power 4? 2 to power 4 is 16. Instead of 16, I can write minus 3. Yes? 16 is minus 3 when it comes to module 19. And minus 3 times 7 is minus 21. So you see, I am using modular arithmetic all the time. Of course, you can take your calculator. This is not a big number, 16 times 7. But instead of multiplying 16 by 7, I just realized that I can multiply minus 3 by 7, which is easier. But everything is good, except that this is negative, but I want to have it positive. So what that number is? What? Is it 16? 17. Yes, because this is in my list 38, so I write 17. Minus 21 minus 17 is minus 38, and minus 38 is divisible by 19. So the answer is that. So 2 to power 100 is congruent to 17 modulo 9. But I hope that you understand, even though this is not the ideal situation, but it is much more efficient if I don't have any calculator. If I don't have any calculator, the only thing that I can do is to calculate 2 to the power 100 and find this one. Yes? Minus 21 minus 17 is minus 38, and minus 38 is divisible by 19. Yes? And 17 is acceptable. Why? Because I want to have it between 0 and 19. Yes? Okay, so you see that this is a little bit complicated calculation. It's not complicated, but you have to keep track of what you're doing, yes? And make sure that you are not making mistakes. I hope that I haven't done any mistakes here. So Yes. Any questions here? So sometimes it is not possible to reach to the ideal situation. For example, I know a little bit more advanced theorem in number theory. So I know that, for example, 2 to power 18 turns out to be 1 modulo 19. Okay? But if assume that if you want to reach to this, might be you have to go down the list until 2 to the power of 18, which is quite beyond our mental calculations abilities, yes? So this is what I am saying, that sometimes it is not easy to to reach the ideal situation, but what you need to do, you start with the one which is closest to the ideal situation, meaning that the base is quite smaller than the other cases. And then, of course, the price that you have to pay is that you cannot reach to this high exponent in one go. You have to raise it to some powers that you can do it in your head. And then when this base goes beyond the module, reduce it and then do the power again with fairly small powers. But it is not, so the good news is that you really don't need to do it 100 times, yes? Because we just did it once here. So we started from here, we raised to power once, 2 times, 3 times, and 4 times. And then we multiplied. So in 5 steps, we actually finalized the problem. Any questions here? Okay, so I will not teach more. We will, I think, go one more session or 2 sessions this week and finalize this number theory and everything included there. Let me see. Okay, let me give you this example before finishing the lesson. So you should be, in principle, be able to solve this problem on your own now. Yeah, this will be the last example here. So we want to find the remainder of this number, 133 to the power of 235 by 16. One hundred 33 to the power of 235. By 16, yes. So in this problem, if you want to start with 133, you cannot make even that list. Yes, 133 to power 2 is so big. But what you are supposed to do? Yes? Yes, so first of all, you have to get rid of 133. Because if you want to follow that strategy blindly, the strategy was telling you that calculate some powers of the base. But even already 133 to even power 2 is so big. But you don't have to work with that high power, high base. You can simplify everything in base 16. Okay, so you can need to find the closest one up to 133. Yes. Okay, so let us solve the problem. So the question is that I have to answer this question. Yes, 235, and then I have to I have to choose module 16, and then I work with R, but I need to know that R should be at the end somewhere here. So this is the question that I ask myself. So then I will start simplifying this in this module. What did you say, Maximilian? 16 times 8 is 128. and then the difference is 5 units. So another name for 133 is just 5. Yes? So instead of that, I write 5. So I just get rid of this one, because 133 minus 5 is 128, and according to this calculation, 128 is divisible by 16. So that is good. But then you can go to a scratch work and then start writing some powers of 5. 5 to the power of 2, 5 to the power of 3, and then 5 to the power of 4. I don't know. These are big numbers, so it is better to stop here. And on the other hand, so you need to write multiples of 16 then, yes? So it's inevitable we have to do that, yes? So because the 16 is still a big number, multiplied by 2, 32, multiplied by 3, 48, multiplied by 4, let us be a little bit patient, 64, multiplied by 5 is 80, multiplied 96, and then 112, and then 128, as you said. So I think we cannot find the ideal situation apparently. So let us work with these two, yes? So this is 5 to power 3. So I would write 5 to power 3 to the power of what? 78, because this becomes 210, 24. Yes, that's correct. And then I need one more, yes? Yes? But what about 125, 128? What can I write for this? Minus 3, yes? Yes? But then I can get rid of this minus sign as well, because that is what? That is even. So I can write it as yes? Yes, that is the ideal situation. So we reach to the ideal situations in 2 steps. So thank you very much. So what happens? I will continue. Instead of this one, I write 3 to power 4, and then raise to which power closest to this? 20 is, so 19. 4 times 19 is 76. I need 3 to power 2, and I have a 5 there. Yes? But 3 to power 4 is 81, and 81 is actually very close to my list here. So this is 1. Another name for 34 is just 1. And then 1 to power 19 is 1. This is 9 times 5, it is 45. 45 is a manageable number, but it is beyond what I need. So instead of 45, I write, no, minus 3 is correct, but not acceptable, because I'm not allowed to give a negative number. Yes? So it should be 13, yes? Because 45 minus 13 is 32. So that's the answer. I want you, I did it in a little bit hurry, because I want you to show GeoGebra as well here. So you can do the modular arithmetic using GeoGebra. So here, if you go to GeoGebra, so we go to cast view again. So let us get rid of the views that we don't need. So, and that is called mod, yes? So if I want to, let us calculate to make sure that we haven't done any mistake. You just write mod, modular arithmetic, and then you choose this one. So the number is, I hope that this GeoGebra is capable of doing these big numbers. So to the power of what? 235. And then what we are supposed to do, the divisor is what? 16. Yes? So if you haven't done anything wrong, that's 13. So this is possible by GeoGebra. So that is 13, yes? So it is good to know that this is the way, that is the syntax that you use in GeoGebra. Let me, by the way, double check the calculation here, so that make sure that we haven't done something wrong. So mod, here we had 2 to the power of 100, and then what was the module? It was 19. What was the answer we got? 17, yes. So the answer is also 17. So it is also very good to check GeoGebra, using GeoGebra, that we have done everything right. So by the way, this is a very big success. This is a very huge number. But in principle, in some lines, we were able to find the remainder. Yeah, so this is really powerful arithmetic when it comes to these kinds of calculations and demands. Okay, any questions? Thank you very much.